Hi, in this video this series of videos we're going to be working through a GCSE paper. Please do stop the video, have a go at each of the questions, then compare your solutions. Each of the videos is going to be about 20-30 minutes or so. It should give you about an hour's worth of fairly focused revision. If you're not sure about anything, always add a comment. I'll come back to you and I look forward to seeing you inside the video.
Okay, in this particular video we're going to be looking at the November 2019 higher tier paper 3 for Edexcel. I'm going to start through from question number 1 onwards, which is an expand and simplify, and this is fairly straightforward. You might do it slightly differently to me, but I would do x times x, which is going to give me x squared. Then I've got minus 9x plus 5x, and then finally minus 45. And when I tidy that up, what I actually get is x squared minus 4x minus 45, and that would be the answer for 2 marks to that one. You might well use a grid method of some sort. That's perfectly fine as well. Okay, so part B of this is factorize, and the important thing here is the word fully. Okay, so what we're looking at is a number which is the highest common factor of 9 and 6, which is going to be 3, and also I've got x squared and x, so actually I can draw an x out of there as well, and that means in the brackets I'm going to get 3x minus 2, and that would be the answer to the part B of question number 1. Okay, let's move on to question number 2, which is using a calculator. Now, all I would do with this is directly put it into the calculator using the fraction key, and what I should end up with is 157.6682255. Okay, and that's perfectly fine for this particular question, because in part B it asks us to give the answer correct to 4 significant figures. Well, the 4th significant figure is 6. I'm going to make it a 7 because the number afterwards is above 5, so that becomes 157.7, and that would be the answer to part B. Okay, let's move on then to question number 3. Scatter graph shows information about a group of students who got a science test and a maths test. It's actually an awful lot of space on the diagram to do this, because we've only got one question which is worth 2 marks, and it says right at the very bottom here, Jamie got a mark of 34 in the science test. Using the scatter graph, find an estimate for Jamie's mark in the maths test. So what I'm going to do is use a line of best fit. Now hopefully this will come out okay on the actual video, but we're going to be looking at something like this. Now there is a variation here. You might have something that's slightly different to me, but hopefully between the two of us we should come up with a reasonable answer. Okay, so he scored 34 on his science test, so what I would do is take 34 from here, take it up to the line of best fit, okay, and then take it across, and that gives me, I think, something like about 39 in his maths test, and that would be perfectly fine for this one. So all you would do is simply just write 39 in the answer part at the bottom there. Okay, let's move on then to something like this. These are very popular type questions. This is an estimate for the mean time. So what we're actually saying here is that there are 18 students who run a race, so this is totaling 18. And then in order to work out, the important thing here is an estimate, because if we look at the first student, actually what we're going to say is that first student achieves an average time of 7.5 seconds. So it'd be 1 times 7.5, which is 7.5. Now it could be true that actually he or she achieved 10 seconds or 6 seconds or any number you like between 5 and 10. However, what we do is we're looking at effectively the average of the average, which is why they use the word estimate. And it's the same story really for the next 2 students. What we say is those 2 students achieved an average time of 12.5 25, so therefore that would be 25 seconds in total. 7 students achieved an average of 17.5, so we're using the midpoints in each particular case, and that just makes our calculation a little bit easier. And then when we get to the end, we're going to add it all up, and that will give us then the total amount of time, which is actually 335 seconds. And then really it's just a case of using this information in the formula, which is mean equals, now the way I remember it is total divided by number. Okay, it's all the numbers when you add them all up together are going to give us, in this particular case, 335, and then there are 18 students, and therefore when I divide one by the other I actually get 18.6, and then it's 1 recurring. Now you'll notice in the question it says give your answer correct to 3 significant figures. So to 3 significant figures, that would be 18.6 on question number 4. Okay, let's move on then to question number 5. Please do stop the video, have a go at each of these questions. If you're not sure about anything, always let me know in the comments, and I can put you a playlist, or put you in the direction of a playlist that might be helpful. Okay, this is quite a common question as well that people tend to not get quite right, because what we're looking at is effectively a cube. So if I just draw this as a cube with a volume of 37 centimeters cubed. Now I know it's completely out of scale, but if I made this 37 centimeters, this would be a height of then 1 centimeter and a depth of 1 centimeter, and therefore the total volume would be 37 centimeters cubed. Okay, but what they want us to do is to do exactly the same, but do it in millimeters. So therefore, if I draw the same cube, but this time I'm going to make my measurements in millimeters. So rather than having 37 centimeters, I've actually got 370 millimeters. And then rather than having 1 centimeter, I've got 10 millimeters. So therefore, when I multiply all of this out, I actually get 370 multiplied by 10 multiplied by 10, which means my total volume is actually going to be 37,000 millimeters cubed. So just be very careful. It's not a linear relationship, it's a cubic relationship. Okay. Question number 6 then. So Nemo is driving to a hotel. He looked at his sat-nav at that time. He arrived at the hotel at that time. Work out the average speed of his car. Okay, this is again quite a common question. We seem to be doing a lot of common questions at the moment. Let's look at the formula. So speed equals distance divided by time. Okay, and that's, most people know that formula. The problem you've got with this particular one is that actually if he took from 1330 to 1448, it's actually 1 hour and 18 minutes, and we're looking for his speed in miles per hour. So what I'm going to do is I'm actually going to change that to 78 minutes, and then for the time I'm going to make it 78 out of 60. So the distance is going to be 65 miles, and then the time is going to be 78 out of 60. And what that will do is it gives me hours. 78 divided by 60, because there's 60 minutes in an hour. Okay, and then when I put that as my calculator and using your fraction keys, it should give you a very nice answer of 50 miles per hour, which is his average speed for the journey. Okay, just a nice little trick there. Just be very careful with those sorts of questions. Okay, let's move on then to question number 7, which is a standard form, and it says write this number in standard form. Okay, so all we're doing really is counting the number of decimal places from the end. So that's 1, 2, 3, 4, 5, 6, 7. So remember, standard form has to have a single digit at the beginning and then the decimal places, and then we're telling them the decimal point has moved 7 places. Okay, so let's have a look at writing that as an ordinary number. Well, again, if I look at 4.96, it's telling me I'm going to move it minus 3 places. So in other words, 3 places in the opposite direction. That's 1, 2, 3. There goes my decimal point. So I've got 2 zeros in that place. So it's common convention to put a 0, then a point, and 00496. Just a comment here, please do make your decimal points nice and clear. As an examiner, it's very hard sometimes to sort of pick out those decimal points, so just be very clear, or as clear as you possibly can be. Okay, let's have a look at that. And again, we're being asked to look at 2 numbers. I think probably for me, the easiest way to do this would actually be to write them out in their entirety. So A is equal to 6.212 times 10 to the 8. So what I'm going to do is I'm going to write it as 6212. So what I've done there is I've moved the decimal point effectively 3 places, 1, 2, 3, and then I'm going to move it another 5 places. So that's 1, 2, 3, 4, 5. And I'm going to do the same with B. Okay, with B, I've got 473, so that's 473, and that's now 2 places, but I need to move it another 7 zeros. So 1, 2, 3, 4, 5, 6, 7. Now you'll notice what I've done is I've actually made all of the digits line up, and that hopefully clearly tells me then therefore that A is actually smaller than B. So I'm afraid ASMA is not correct on that particular issue. A, if you line up all the decimal places, A is actually smaller than B. Okay, let's move on then to question number 8. It's a diagram showing a regular pentagon and a parallelogram. Okay, so we've got to be a little bit careful here, just working through things fairly methodically. So what I'm going to do is I'm just going to concentrate on the parallelogram first, because what I know about a parallelogram is that angles in a parallelogram add to 360 degrees because it's a quadrilateral, it's a 4-sided shape. I also know that opposite angles are the same, so therefore this must be 117 degrees. Okay, so what I'm going to do is I'm going to say, well, that must be 360 minus 117 minus 117 as well is going to give me the angles that are the 2 angles at either side of the parallelogram, which is actually going to be this angle and this angle. Now again, they're both going to be the same, so 126 divided by 2 is going to mean that each of those angles is 63 degrees. So I know this one is 63 and this one is 63. Okay, so now let's have a look at the pentagram itself. Well, the pentagram, now again, there's a couple of ways of doing this. I've seen people use formulas, but what I'm going to try to do is work out the interior angle of the pentagon, because what that does then is it allows me to take 63 away, and if I know this interior angle, I take 63 away and that will give me the value of x. Okay, so you can use a formula to do this. Just as an aside, I tend to, or I could do a little sketch here, and then if I pick one of the corners, what it's telling me is that I can break up the pentagon into 3 triangles. So I've got 180 multiplied by 3 is going to give me 540. Now I know there's 5 angles altogether, therefore the interior angles are going to equal to 5 into 540, which gives me 108. Okay, so therefore each of the interior angles of this pentagon is 108 degrees. Okay, so it basically means then that to find angle x, well, that's going to be 108 take away 63, which is a fairly straightforward then, so x equals 108 minus 63, which is going to give me 45 degrees. So therefore the answer for 4 marks is actually 45 degrees on this particular question. Okay, we're going to keep working through for about another couple of questions or so, and then I'll stop the video. Please do let me know in the comments if there's anything particular that you're not sure of, and I'll always be delighted to help. Okay, let's have a look at number 9. Number 9's one of those where we need to enlarge the triangle by a scale factor of 2.5 with a center 0. So this is one of those type of questions where hopefully it'll be okay on the video. I'm just going to mark in first some lines of enlargement because it just helps my calculation a little bit more. So this is going to go along like that, and then I'm just going to take the ruler and I'm going to spin it a little bit, and I'm going to go through this corner here. The way I describe it to my students, at least, is that it's a little bit like standing at the point 0,1 with the world's most powerful torch, like the kind of Batman torch. And then what we're doing is we're going to create a shadow. We're shining it onto a building, and we're going to create a massive great shadow behind it. And the way to do this properly really is to use vectors. Okay, so the first vector I'm going to say is if I look at the point A, which is this point here. Well, in order to get to A from 0, 1, I've gone along one jump and I haven't gone anywhere along the y-axis. So let's have a look at that. I'm going to say it's to get to A, it's going to equal to a vector of 1, 0, and then I'm going to multiply that by 2.5 because I want it 2.5 times bigger. So therefore now my new vector will be 2.5, 0. So actually I can go from 0, 1 again, and this time I've got one jump, 2 jumps and half a jump, and that's going to put me here, which is my new point for point A. Okay, let's do exactly the same then with point B, which is going to be this here. Okay, now again, don't worry too much about keeping these diagrams clean and tidy. You know, you really want to make sure, maybe use pencil if you want to, but you really want to make sure that you show the examiner that you know what you're talking about. So if I go to point B, and hopefully it's not going to be too much on the screen, I'm going to go along 2, and then this time I'm going to go up 2. Okay, so remember it's always from the center of the origin, not the center of the center of enlargement, which in this case is going to be 0, 1. So point B is going to be a vector of 2, 2. Okay, I'm going to multiply that by 2.5. So therefore now that's going to be a vector of 5, 5. And if I go back, that's going to give me 5 jumps along. So that's all the way to here. And then it's 5 jumps upwards, and it's all the way to there. And that's going to give me point B1. Okay, now if I've done my job correctly, then the new location of each of the vertices is going to be on the lines of enlargement. So it just gives me that level of kind of confidence that I'm doing the right thing. Okay, let's move on then to point C, which is this one here, and that's a vector of 1, 2. Okay, so point C, and hopefully you can follow this along, is going to be a vector of 1, 2. And then I'm going to multiply that by 2.5, and that's going to give my new location of 2.55. Okay, so that's going to be along to 2.5 and up 5 jumps. Okay, I didn't draw that line particularly well, but that's going to be my new line, point C. So therefore the enlargement itself is going to be this one. Now again, if you're not sure, let me know, because I've got some other worksheets that you can have a look at, but that would be the enlargement of the triangle. Okay, let's move on then to question number 10, which is going to be the last one on this particular video, which is solving for x. Now, it's a bit awkward because we've got 7 as a denominator. So what I'm going to do is multiply across by 7. What I actually get is 9 plus x equals 7 times. Remember, I'm multiplying both of the terms. So I'm going to use brackets, and then I'm going to get rid of the brackets. So it's 9 plus x equals 77 minus 7x. Okay, minus 7x is not particularly helpful, so I'm going to add 7x to both sides. Now if I do that, I get 9 plus 8x equals 77. Okay, and then I need to get that 9 to the right hand side, so I'm going to minus 9. Remember, the object really is to get x on its own, so at the moment I've got 8x equals 68. Okay, and then finally I'm going to divide by 8, and that gives me one value of x, which is going to be equal to 8.5, and that would be the answer to question number 10. Okay, and then very finally here, let's move on to part B of this. This isn't too bad really, it just looks a little bit awkward when you look at it, but if we multiply all of this out, I'm going to get y plus 3 times, or expand it out really, 3 times y plus 3, and that's all divided then by y plus 3 squared, so it's y plus 3 times y plus 3, and then really I can just simplify this through. I'm going to do that one and that one and that one and that one, so what I get left with is 4 times y plus 3, and if you want to you can expand that out, you can get 4y plus 12. It won't really matter whichever way you write it for the purposes of the marking scheme. Okay, I hope that's been useful, and I look forward to seeing you inside the next video, where we're going to start with question number 11 onwards.